नमस्ते बच्चों, हमेशा खुश रहो। माई सेल्फ जेविन डॉक्टर मोनिका त्रिवेदी. The today's topic is a factor affecting the stability and liability of complexes. This topic belongs to Inorganic Chemistry 2nd, M.Sc Chemistry 2nd semester. There are some factors which affects the stability of the complexes, like charge on the central metal ion, radius of the central metal ion, coordination number, type of ligands. So these are some types, these are some factors which affect the stability of the complexes. The observation of kinetic stability, like species result of the many several factors are affect the stability of the reaction, like charge on the central metal ion. If you can see here the example, if you see the charge varies on the complexes, the stability of the complexes also decreases. Okay, if the charge increases, the stability decreases. If the radius of the central metal ion, you can see here the radius increases, the stability increases. Okay, by the increasing the radius of the central metal ion, the stability also increases. If the coordination number of a central metal ion increases, like a tetrahedral or a square planar complexes exhibit a higher liability towards the isotope ligand exchange compared to the octahedral complexes. This is because the availability of large room for the entry of the incoming ligands increases the four coordinates of the complexes. Okay, the next is some factors which affect the thermodynamical stability, like charge, radius, but on a central metal ion. Okay, so the value of stability constant for the example, like if FeCN if FeCN plus 3 and the Fe plus 2, the you can see the charge on Fe is different, so the stability also changes. If you can talk about the radius of the hydroxide of the magnesium is 0.65 angstrom, has a 4 times greater value of the stability constant as compared to hydroxide of the calcium. Okay, because the radius is different. Okay, next is a crystal field stabilization energy, like CFSC. What is CFSC? If you see the order of d orbital of CFSC, if you calculate the CFSC for this d orbital, you can see the stability increases by d0 to d3. Then the stability of d3 and is greater as compared to d4, and then the stability of d5 to d7 increases, and then it decreases by d10 d9. Okay, so this is the crystal field stabilization energy for any metal ion. Okay, if we know, like if the type of metals if are different, the stability also changes with the type of metal. If the class A type of metal, like sodium, aluminium, calcium, titanium and iron, okay, and the lanthanides, the stability complexes with ligand having a coordination atom of the second prior element, like NOF compound, you know? Okay, so the stability is greater. And if the class B kind of the ruhedium, palladium, silver, iron, iridium, platinum, okay, orium and mercury. Okay, so the stability complexes with the ligand having a coordination atom from the third period of the element, like PSCl compound have a higher stability of complexes. Like if you see the ligand, if you see the stability of ligand, if type of ligand changes, the stability also changes. If the ratio of charge on a size on a ligand, okay, the greater negative charge occupied with the similar size gives a higher value of the ratio. Thus the stability constant of a fluorocomplexes is 10 times higher as compared to chloro complexes. Okay, or if the basicity of the ligand, the stronger Lewis base readily donate the electron pair for the complex with the greater stability and in line of this, ammonia form more stable complex as compared to water, which is turned form more stable complexes than the hydrofluoric acid. Okay, what is a Killet effect? Killet effect, the complexes containing the Killet ring are generally more stable than those who have a without a ring structure. Okay, the value of stability constant for the that ammonia complex is less because doesn't have a Killet ring or in any kind of ring formation. So if you see the Killet ring present in the molecule, like polydentate ligands use more one of the coordinating atoms to more ring involved in the metal ion. Here the Killet effect increase the stability of complexes. Okay, the number of Killet ring, as you see in a previous example, the number of Killet rings are present, the stability increases more. If you see the ethylene diamine ligand, diethylene tetraamine ligand are capable for more or two Killet ring respectively, so their stability is increases as the number of Killet ring increases. Okay, and the steric hindrance like a nickel complex of the oxime has a higher stability constant value as compared to along with the another 2-methyl 1,8 hydroxyquinone, because the steric hindrance restrict the stability of the complexes. Okay, so these are some kind of factors which affect the stability of the complexes. Some factors affects of the central metal ion, and some factors affects the ligands, the stability of the complexes. Okay, this session is powered by digital version 2.0 Jyoti Vidyapeeth Women's University. Hope you satisfied with my session, and if you have any query, please comment me. Thank you.